Hello everyone, especially to our lecturer, Dr. Ain Miti NAZARI. So right now, today we will present to you the assignment, the group assignment for this subject, which is the subject of BEJ34202 Vision System. And the title for this group assignment is Recyclable Material Classifications by using Convolutional Neural Network CNN. So I will proceed to introduce my team member. So we are from group 9, and the first team member is Henry PARAN ANAK NEGRO, and the matrix number is CE180019. And me myself, my name is JANIS, and my matrix number is CE180032. And the last one is Mama AZLAN bin ROSLAN, CE180011. So right now we will proceed to the introductions for this assignment. As we may see that recycling is important both economically and environmentally. For a more sustainable future, it is critical to keep an effective recycling system in place. Despite the importance of the industry, the recycling process is currently heavily reliant on human abilities. Recycling materials classifications is a difficult subject that necessitates meticulous procedure in order to produce a reliable dataset. So the convolutional neural network CNN is a class of deep learning neural networks. The pre-trained models that we had used for this project are CNN, VGG, and DenseNet. So what is convolutional neural network, CNN? It is a type of a deep learning neural network. CNN are significant step forward in image recognitions. CNNs are frequently used in image categorizations and are widely used to evaluate visual informations. So in this study, in this assignment, CNN, VGG, and DenseNet CNN VGG were used as a pre-trained model. Convolutional neural network, CNN, are the type of deep artificial neural network. CNN are used to classify image, group them based on the similarity, which is the photo shows, and recognize object within scenes. Meanwhile, GoogleNet has an inceptions module that uses tiny convolutional layers to help with parameter reductions. The result of this model will be used to determine the best method to categorizing image. So for this project, we had focused on the ability to distinguish between trash item and recyclable item, which is the can and also PET. So for this project, we have built the CNN models for the training without overlifting or underfitting the data in this project assignment. So what is overfitting? So overfitting is the good performance on the training data, poor generalization to other data. And the underfitting is the poor performance on the training data and poor generalizations to other data. So as you can see here, this is the output waveform or the output graph for the overfitting. This one is overfitting, and this one is underfit, and this one is just right. So I think that's all from me for these introductions. I will pass it to my team member. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad AZLAN. My matric number is CE180011. Okay, for methodology for this assignment is, we can see first methodology is convolution neural network CNN, second is visual geometry group BGG16, and then dense convolutional network DenseNet. Okay, we go to next slide. Okay, for the convolutional neural network, as you can see, this is the figure. Okay, as you can see, for the first is the term convolution refers to the mathematical combination of two functions to produce a third function. After that, it merges two sets of information. In the case of a CNN, the convolution is performed on the input data with the use of a filter or kernel. Lastly, for the convolutional neural network, is the most beneficial aspect of CNNs is reducing the number of parameters in artificial neural network (ANN). For second method, visual geometric group BGG16 is a convolution neural network that is 16 layer deep. BGG16 has roughly 138 million parameters. For the next is BGG16 has roughly 138 million parameters. Lastly, BGG16 was born out of the need to reduce the parameter in the convolution layer and improve on training time. Okay, for the last methodology, you can see the dense convolution network dense net. Okay, this is the picture as you can see. The picture. Okay, the dense convolutional network dense net is a relatively recent development in the field of neural network for visual object identification. ResNet is fairly similar to ResNet with a few key distinctions. ResNet employs an additive approach. Plus, for combining the previous layer's identity output with the future layer, whereas ResNet concatenates the previous layer's output with the future layers. Okay, for the task one, as you can see, this is a program that we run from the Google Colab. Okay, you can see this. The data set input for this CNN total are 148 times 148 pixel inside the convolution 2D layer, convolution layer that deal with 2D metrics as input pictures. This training model has 4 convolutional 2D layer in this case. The number on the first and second layer indicate the number of nodes in each layer, which can vary depending on the size of the dataset. Okay, as you can see, these are training and validation accuracy. Okay, as a consequence, it was discovered that the training accuracy average is 1.0%, while the validation accuracy average is 0.9%. Although the accuracy rate is acceptable, there is still overfitting due to the gap between the training and validation accuracy curve. Next is training and validation loss. Okay, the fact that training loss is lower than the validation loss indicates that the model is overfitting, as the validation loss curve also shows a bit of noisy movement around the training loss at the start of the curve. For the task one, we take a picture from different for the task one, we take the 3 types of picture. First, side. Second, can front. And the third, the bottle front. Okay, as you can see, this is the Google Colab for the task one that we program to fulfill the assignment. Okay, after that, we run this code after we do the connection, and then we wait to the result. Okay, the program is still running. Okay, after run, this is the result that we get. Okay, this is a graph, you can see. So that's all for me. Thank you.
Hi, my name is PARAN, manager number CA180019. Today I'm going to present how to demonstrate the task 2 in the group assignments. So as you can see, I already opened my Google Colabs. To start is we have a add step, and the step 1 is the connect to Google Drive. So in my Google Drive, I have already add the Colab notebook folders, and I put in a dataset, which is the folder, which are model.m1, test, try, and validations. So going back to Google Colabs, and the data directory is I put the link here for the Google Drive, which is the file. To step 3 is try and validation data directory. So we have with my alt the data Google Drive, which is the file of the data sets. So there I have CanTran 156 and PenTran 310. Convolution I have 77, and so step 4 is construct pre-trained model with BEJ34202 for variation is right here, look here. So the step 5 is construct pre-trained model with density net, and the first model is sequential, so layer tabs is here, is BG16 functional, for example JANIS 44512, and flatten, dense 1, dense, and non-ones. And we have step 6, which is the pre-processing the input data, and we have the, since we use binary conversion loads, we need to enable so the instructions set. So the start training process is show the high variation process. So the low of the has the accuracies, and the final step is the plot the outcomes. So as you can see, we look to our training and validation accuracy. It's starting from 0 until 8. And also the second is the starting from 0 until 8. So, and that's all from me. Thank you.
So we have come to the conclusions for this assignment. In this project assignment, our group pre-trained 3 different models classifications. The classification problem can be well addressed by using transfer CNN models, which were able to learn effective features based on the pre-trained models and better performance in recyclable material classifications. There are 3 types of models. CNN model trained traditional classifications, model with handcrafted features, and 2 transfer learning models built with pre-trained CNN model, which is DenseNet and BGG. So we also use the LXNet in this assignment for the task 2. Combining transfer feature from CNNs could further improve the classification's accuracy, especially for this, just like we have done for the recyclable material classifications. So I think that's all from our group. Thank you.